Hello, Leiden geometry students. In this assignment, we're going to talk about triangle inequality. That's things that are not equal to each other. It's going to be important to remember in a few minutes that these things are not supposed to be equal, but they're supposed to be greater than or less than. We'll get to that in just a moment. First, let me explain how we would do this normally if we were in class together. Normally, we'd take a bunch of pencils and gather them up together and then find a saw and cut those pencils up into a bunch of little bits. And then we're going to throw away all these little bits here that we're not going to use, and we're just looking at those long parts of these pencils. Next, I would offer a piece of candy. I'd put up three of these little parts of pencils and offer a piece of candy and say, anybody who can come up here and make a triangle using the full lengths of these pencils can have this piece of candy. And people aren't very eager to volunteer, but eventually someone will raise their hand. They'll come up and start rearranging these pencils, and they'll make a little triangle out of the three pencils like this. And then they take the piece of candy, all happy, and go back to their seat. And all the other students are like, oh, that was really easy. And I say, that's okay, that was the easy problem. Let's try a little bit of a harder one. Next, I'll offer you a bag of Skittles to someone who can come up and make a triangle out of these three segments. A few more hands come up, and somebody comes up and they start rearranging these pencil pieces, and they make a triangle out of these three. And all happy, the student goes back to their desk and eats some Skittles. And then I say, okay, I made that too easy. Let me make a slightly harder one. Anybody who can make a triangle out of these three parts can come up and take this bag of cookies. So a student raises their hand. This time everybody will raise their hand and want to volunteer because, hey, free cookies. And then they come up and they start grabbing the pencil pieces and trying to arrange them to make a triangle. And first, the student will do something like this, but these two pieces won't reach each other. So they'll grab the pencils and rearrange them, and then try doing something like this. But they can't connect this little short side here to the end of this. So they keep rearranging, and then eventually they come up with this again. Now the student's getting frustrated, and eventually just starts putting it together and says, here, how about this? Is this okay? And I say, no, you shortened this one side. I want to use this full length. And at this point, the student usually gets very angry at me, gets upset, runs away, goes, sits back down their seat, and they say they give up, and then they probably say something terrible about my mother. And then I tell them, don't feel bad, you couldn't do that, because this is the T-Rex problem. And they say, what's the T-Rex problem? I draw a big Tyrannosaurus on the board. I say, this is the T-Rex problem. What is this Tyrannosaur missing? His little tiny Tyrannosaur arms, and that's the whole point. Tyrannosaur had little tiny arms. They were so short he couldn't even clip his own fingernails. And that's what's going on with these pencils. The arms are too short. See, if this is the Tyrannosaur, and we give him these little tiny arms that can't actually reach each other, you could never make these actually connect to each other. One side is so much bigger, it spreads the other two sides too far away to actually meet. So, we want to figure out when we can have two sides that can't reach each other, that can't make a triangle. In other words, the two short sides here, they have to be long enough to reach each other. So our two short sides in a triangle have to be longer than the one long side. I'm going to say that again, that's an important rule. The two short sides of a triangle have to add up to more than the big side or they won't reach each other. So here's an example of that problem as a math problem. Here I have three sets of sides I want to make triangles out of. I can do it with two of them, but in one of these three cases, one of the sides is so much bigger than the other two, they'd have these two little short sides that won't reach each other. Which sets of sides are too big to actually reach each other? And it's this 3, 4, and 50. Why? Well, if we start with the 50, here's a segment that's 50 inches long. If I put a 3 on one side and a 4-inch on the other side, they're going to be too short to reach each other. So we can't actually make a triangle out of these. You can't actually make a triangle out of these three either, because as we said just a few moments ago, the two short sides have to add up to more than the big side. And in this case, the two short sides don't add up to more, they add up to being equal to the large side. So in that case, they can't make a triangle either. The rule again is that the two short sides have to add up to more than the one long side. So one more time repeating that, the two short sides have to add up to more than the long side. In math, this isn't a technical definition, so in math we would actually write this a different way. We'd say in a triangle with side lengths A, B, and C, A plus B has to be more than C. Any two sides have to add up to more than the other side. So, for example, here's a problem. I'll do the one on the left. I'm going to ask you to take a look at the problem on the right. Here, we want to know if we can make a triangle with side lengths 4, 7, and 13. Now, we don't know if this is inches or feet or meters, but it doesn't matter. All we have to do is check if the two short sides add up to more than the one long side. So step 1, identify our two short sides. That'll be the 4 and the 7. And we need to find out if they add up to more than the one big side. Is 4 plus 7 more than 13? No, it's not. 11's not more than 13. So in this case, no, we cannot make a triangle with side lengths 4, 7, and 13. Could you make a triangle with side lengths 8, 12, and 19? Well, again, we check if the two smaller numbers add up to more than the big number. Is 8 plus 12, the two small ones, does that add up to more than 19? Is 8 plus 12 more than 19? Yes. So in that case, we could make a triangle with those side lengths. So here are 3 problems to check, and the answer is a simple yes or no. Can these 3 lengths make a triangle? In the first one, the two smaller lengths, 5 and 7, does that add up to more than 9? 5 plus 7, is that more than 9? Yes. So yes, we can make a triangle here. In the second problem, the two small lengths, 3 and 12, does that add up to more than 20? 3 plus 12 is more than 20? No, that's not right. So no, you cannot make a triangle here. The third one has a trick to it. Make sure you're comparing the small ones to the large ones. See, in the third one, you have to add the 10 and the 8. Those are the two small sides. Is 10 plus 8 more than 16? Yes, you can make a triangle with those 3 side lengths. Okay, that's the easy version of the problem. The hard version looks like this. If I give you 2 sides of a triangle, can you tell me what the third side could be? In other words, if I told you a triangle has side lengths 8 and 15, what are the possible measures for that third side? Well, there's tons and tons of numbers in the universe. Here's a whole bunch of them up to 100 and keeps going. And what I want to know is which of these numbers could be the third side. Well, I'll start with an extreme and obvious case. If the third side was 100, 8, 15, and 100, well, 8 plus 15 is not more than 100, so 100 is definitely a no. And I can keep going down until I get to much smaller numbers, 99, 98, 97. None of those will work. If I come down to 39, is 8 plus 15 more than 39? No, it's not more than 38. It's not more than 37. 8 plus 15 is not bigger than 35, and you can keep checking these. And you can go through and keep checking numbers over and over. But the fast way to get to the answer is to say, well, 8 plus 15 is 23. So 23 is really the first number I have to check. Okay, if the third side was 23, is 8 plus 15 more than 23? No, 23 doesn't work. But anything less than 23 will, because 8 plus 15 is 23. So if I had 22.7, 8 plus 15 would be 23. That's more than 22.7. So anything less than 23 would work. But actually, not anything. What if we go down to the other extreme? What if we went to the number 1 here? If my third side was 1, the two small sides now are 8 and 1. Is 8 plus 1 more than 15? No, so 1 wouldn't work. How about 8 plus 2? Is that more than 15? No, so 2 won't work. The way to find the other limit here is we're simply going to subtract these numbers. We'll take the bigger one minus the smaller one. What is 15 minus 8? It's going to be 7. If I had 7 for my third number, 8 plus 7 is equal to 15. That doesn't work. But if I had 7.1, 8 plus 7.1 would be 15.1, and that is more than 15. So any of these numbers between 7 and 23 would work. Our answer has to be between 7 and 23. In math, we would write that as x is more than 7, but less than 23. Now notice it's not greater than or equal to, it's not less than or equal to, because 7 itself doesn't work, 23 itself doesn't work. You can jump straight to these numbers by simply adding and subtracting the two side lengths that you have. For example, 511 blank. What could this third side be? Well, there's an upper limit, it can't be 1,000, and there's a lower limit, it can't be 1. How do we find those limits? Really easily. We simply add the two numbers together, and we subtract the two numbers from each other. See, 11 minus 5 is 6. That's our lower limit for the third side. The upper limit is 11 plus 5. We get 16. So our answers, the third side, would have to be between 6 and 16. It has to be between those. Actual 6 and 16 don't work. It has to be between them. Mathematically, we would write that as x is more than 6 and less than 16. Or you could switch the order of this. It doesn't matter which way you write it. But basically, we're saying that x is between 6 and 16. Again, we found those two numbers, those limits, by simply adding the two sides and subtracting the two sides that we had. If you subtract them and get a negative, then just switch the order. If you do 5 minus 11, you'll get negative 6. But then you just switch it and do 11 minus 5 to get positive 6. We're not doing triangles with negative side lengths. Take a moment and find the upper and lower limit for the second set of numbers, 12 and 15. Okay, for this problem, we're simply going to find the upper and lower limit by just adding these numbers and subtracting these numbers. The lower limit, 15 minus 12 is 3, so our third side has to be more than 3. And the upper limit, 15 plus 12 is 27. The biggest side has to be less than 27. So we say our answer has to be between 3 and 27, which we write like this. X is between 3 and 27. And again, you could write it this way or this way. So take a moment and try to find the possible answers for the third side in each of these problems. In the first problem, our sides are 2 and 7. We simply add them to get 9, subtract them to get 5, and our third side has to be between 9 and 5. In the second one, number 5, we are simply going to add these numbers and subtract these numbers. When we add them, we get 51. When we subtract them, we get 9. So our third side has to be between 9 and 51. In the last problem, I have two of the same numbers. That's okay. You still follow the same rule. 5 minus 5 is 0, and 5 plus 5 is 10. Our answer has to be between 0 and 10. You might think, how could I have a side length of 0? You don't. We're saying it has to be more than 0. So 0.001, we could make a triangle, but 0 itself does not work. Next, we're going to combine this idea with our rules about isosceles triangles to get another really simple rule. Remember back at isosceles triangles, we identified which angles were congruent by looking at which sides were congruent, and vice versa. Well, the same thing works for the larger and smaller sides. See, if I told you that this side down here, QB, was the biggest side, you can tell what's the biggest angle. If this is the biggest side, then the biggest angle is the angle across from it. The angle across from it would have to be the biggest angle. Now this triangle is marked so it's isosceles, so this other angle would match as well. But let's take away those marks for a moment. And here, even if we don't know what the measurements of any of the sides are, if we know one of the sides is the biggest, then we can always find the biggest angle. It works in reverse as well. Let's say in this second triangle, if I told you that this side over here is the smallest side, which angle would have to be the smallest angle? The smallest angle is across from the smallest side. So the smallest angle would have to be across from that, which is going to be angle M. So we could give you a problem. Here, if I give you the three side lengths of a triangle, here's a triangle, Side AB is 14, side AC is 20, and side BC is 22. Can you find the smallest angle, and then the medium angle, and the largest? Well, the trick to doing this is to draw the picture. And based on the letters we have, A, B, and C, I just draw a random triangle, ABC. I'm going to list the sides by the lengths I'm given. AB is 14, so I put a 14 here between A and B. AC is 20, so between A and C we put a 20. And then BC is 22. Here we can tell our three sides. And if we want to start with the smallest angle, well, the smallest angle has to be across from the smallest side. So if the smallest side is 14, what would be the smallest angle? It's the angle across from it. Angle C has to be the smallest angle. And then the medium angle will be across from the medium side, 20, so B. And the largest angle and largest side are across from each other. So since BC is the largest side at 22, then A is the largest angle. Take a moment and try to list the angles from smallest to largest for this other triangle. Step 1 is to draw a triangle. Here we can draw a triangle using those same letters, X, Y, and Z. It does not matter where you put the X, the Y, or the Z, but once you have the letters in, you put the numbers in the right spots. XY is 31, XZ is 50, YZ is 28. So what's our smallest angle? It's across from the smallest side. The shortest side here is YZ is 28, which means the smallest angle will be X. The medium angle will be across from the medium side. 31 over here is our medium side, so angle Z is the medium angle. And the largest angle is across from the largest side. If XZ is 50, then Y would have to be the largest angle. This kind of problem works backwards as well. If we're told the three angle measures of the triangle, angle A is 30, B is 60, and C is 90, we can draw a picture. It's a triangle ABC. You just draw a triangle, label it ABC. And then we're going to plug the angle measures into the appropriate spots. Angle A is 30, B is 60, C is 90. This is not drawn to scale. I know some of you are thinking that's not a 90-degree angle, but you don't have to have that right. We're just looking at the measures. If we want to name the sides from shortest to longest, the shortest side has to be across from the smallest angle. The smallest angle is 30, so the shortest side is BC. The medium angle is 60, so that's B, so the medium side will be segment AC. And the largest angle is 90 here at point C, so the largest side will be segment AB. I'm sorry, I had the answer written backwards. I had longest to shortest. The shortest to longest should be BC, then AC, then AB. Let's try that in the last one. Angles X, Y, and Z. So draw a triangle XYZ. Throw in the angle measures. Then figure out which side is the shortest, the medium, and the longest. Well, here's our triangle, XYZ. We put the angles in the right spot. Angle X is 30. That's the smallest angle. So the shortest side has to be across from that. It's segment YZ. The medium side, or the medium angle, angle Z, is across from side YX or XY. And the largest angle has to be across from the largest side, so our largest side is XZ.